Welcome to Milky Narratives. Tonight, leave behind the noise of the waking world, relax your mind, and drift with me into the quietest mysteries of the universe. Every second that passes, parts of the universe become permanently unreachable, as if reality itself is quietly deleting chapters from its own story. The universe is disappearing. Not all at once, not in some dramatic explosion of stars or a sudden collapse into darkness. The process is far quieter than that. In fact, it is happening so gently that no human being has ever noticed it with their own eyes. And yet, right now, as you lie beneath the night sky, entire regions of the cosmos are slipping beyond our reach forever. Galaxies are vanishing from possible contact. Ancient information is being lost. Future civilizations may never know those places existed at all. It is as if reality itself is slowly turning the pages of a book and quietly tearing some of them away. Tonight we are going to explore one of the strangest ideas in modern cosmology, the possibility that the universe is gradually erasing parts of its own history. Not because something is destroying it, not because the stars are going out, but because space itself is changing. And as it changes, pieces of the cosmic story are being carried farther and farther away, beyond any signal, beyond any journey, beyond any hope of recovery. The deeper scientists have studied the universe, the more surprising this realization has become. For centuries, humans assumed that knowledge could always expand. Given enough time, enough patience, and better instruments, perhaps every mystery could eventually be solved. But the universe may not allow that. Some knowledge has an expiration date. Some evidence is only available for a limited time, and we may be living during one of the rare moments in cosmic history when the universe is still willing to reveal much of its past. That thought is both unsettling and strangely beautiful, because it means the night sky above you is not permanent. The universe you see today is not the universe future observers will see. In a very real sense, we are living during a special chapter of cosmic history, a chapter that will never come again. To understand why, imagine standing on the shore of a vast ocean. At first, distant ships are visible on the horizon. You can watch them moving slowly across the water. But eventually, they become too distant. They shrink, they fade, and finally they disappear beyond sight. The ships still exist. They have not been destroyed. They are simply too far away to observe. Something surprisingly similar happens across the cosmos. The difference is that the distances involved are almost impossible to imagine. Galaxies are not separated by kilometers, or even by billions of kilometers. They are separated by millions and billions of light years. A light year itself is the distance light travels in an entire year, and light moves faster than anything else in the known universe. Even at that incredible speed, crossing the cosmos takes immense amounts of time. This is why every telescope is really a machine for looking into the past. When astronomers observe a galaxy a billion light years away, they are not seeing it as it exists now. They are seeing light that began its journey a billion years ago. The galaxy they observe today may already be different. Stars may have been born, stars may have died, entire structures may have changed. The light arriving at Earth is simply an old message finally reaching its destination. For a long time, scientists assumed that although distant objects were difficult to reach, the universe itself remained fundamentally accessible. But then, a startling discovery changed everything. In the late 20th century, astronomers found evidence that the expansion of the universe is accelerating, not slowing down, not remaining constant, accelerating. The distances between many galaxies are growing faster and faster over time. Something mysterious appears to be driving this expansion. Scientists call it dark energy, and although we do not fully understand what dark energy is, we can observe what it does. It stretches space. It increases separation. It slowly pushes distant regions of the universe farther apart. The consequences of this discovery are profound. Imagine sending a message toward a distant galaxy. The signal travels at the speed of light. It races through the darkness exactly as physics allows. Yet the space between you and that galaxy is expanding. The destination keeps moving away. In some cases, the gap grows so rapidly that the signal can never arrive. no matter how long it travels, no matter how much time passes. The message loses the race forever. This creates a remarkable boundary, not a wall, not an edge, but a limit to communication itself. Beyond that limit, regions of the universe become permanently disconnected. They still exist, but they can no longer exchange information with us. And this is where the idea of cosmic forgetting begins, because information is the foundation of knowledge. If information can no longer reach us, then part of reality becomes inaccessible. Imagine opening a history book and discovering that entire chapters have faded away. The events happened, the people existed, the stories unfolded, but the evidence is gone. This is, in some ways, what accelerated expansion is doing to the cosmos. Galaxies continue their journeys, stars continue their lives, planets continue circling distant suns, but the information they produce gradually becomes unreachable. The universe is not destroying its past, it is hiding it, and the hiding becomes more effective with every passing billion years. Perhaps the most astonishing part is that this process has already begun. There are galaxies whose ancient light is still arriving at Earth right now. Astronomers can photograph them, measure them, study them, yet those same galaxies may already be beyond future contact. If they emitted a brand new signal today, that signal might never reach the Milky Way. We are seeing their history while losing access to their future. Think about how extraordinary that is. A civilization could observe another galaxy, learn its past, understand its structure, yet never receive another update for the rest of eternity. The conversation ends before it truly begins, and over unimaginably long stretches of time, more and more galaxies will cross this invisible threshold. The cosmic archive will slowly shrink. Future observers may inherit a universe that appears far smaller than the one we know today. A quieter universe, a lonelier universe, a universe that has forgotten much of its own story. Yet there is also something strangely peaceful about this process. The universe is not rushing. It is not collapsing into chaos. The change unfolds over timescales so vast that entire civilizations rise and fall in the blink of an eye compared to cosmic history. Stars continue shining. Galaxies continue turning. Gravity continues shaping the great structures of space. The universe remains magnificent. But beneath that magnificence, an invisible transformation is taking place. A gradual fading, a slow retreat of information into unreachable distances. And tonight, while you rest beneath the stars, that process continues, silently, patiently, second by second. The universe grows older. Space expands a little more. And somewhere beyond our sight, another tiny fragment of cosmic history drifts beyond the reach of any future observer. Not destroyed, not forgotten entirely, simply carried away into the immense darkness of an ever-growing cosmos. 2. You are living during the brightest era of the cosmos. The universe you see tonight may be the richest view of reality that any civilization will ever experience. That sounds almost impossible at first. After all, we often imagine the future as a place of greater knowledge, more powerful telescopes, and deeper understanding. We picture civilizations millions or even billions of years ahead of us, uncovering secrets we can barely imagine today. And in many ways, they probably will. But there is one strange possibility hidden within modern cosmology. The future universe may actually be harder to understand than the one we live in now. Not because intelligence disappears, not because science fails, but because the evidence itself slowly vanishes. As you rest quietly beneath the stars tonight, you happen to exist during a remarkably fortunate chapter of cosmic history. A chapter when the universe still reveals much of its past. A chapter when distant galaxies remain visible. A chapter when ancient light still reaches us. A chapter that may eventually come to an end. And the strange part is that most people never realize how special this moment truly is. If you could travel billions of years into the future, the night sky might look astonishingly different. The familiar stars would not disappear immediately. The Milky Way would still exist, but much of the larger universe could gradually fade away. The reason begins with one of the greatest discoveries in modern astronomy. The universe is expanding. For nearly a century, scientists have known that distant galaxies are moving away from one another as space itself stretches. At first, astronomers assumed that gravity might eventually slow this expansion. Perhaps the cosmos would continue expanding forever, but at a decreasing rate. Perhaps it would even reverse and collapse. But observations revealed something unexpected. The expansion is accelerating. Some mysterious influence, what we currently call dark energy, is causing distant galaxies to drift apart faster and faster over time. And this changes the future dramatically. Imagine standing on a vast shoreline as countless ships slowly sail away. At first, they remain visible, then they become tiny dots on the horizon. Eventually, they vanish completely. Not because they ceased to exist, but because they moved beyond your ability to see them. Something similar may happen throughout the cosmos. The galaxies we observe today are not permanent features of the night sky. Many are slowly receding beyond our future horizon. Their light still reaches us now, but one day their newest light may never arrive at all. Future observers may know those galaxies once existed only through ancient records left behind by civilizations like ours. Without those records, they might never discover them. And that possibility creates one of the most fascinating ideas in cosmology. The universe may currently be living through its brightest observational era. Tonight, astronomers can look outward and see billions of galaxies. Gigantic clusters stretch across unimaginable distances. The cosmic web connects enormous structures throughout space. Ancient light from the early universe still fills the sky. The evidence for cosmic expansion remains visible. The fingerprints of the Big Bang remain detectable. We can reconstruct a vast cosmic history because the clues still exist. But the universe does not preserve information forever. Expansion slowly carries pieces of that evidence away. The farther future observers look, the less they may find. One day, the galaxies beyond our local region could become completely inaccessible, not merely difficult to observe, truly unreachable. Imagine being born in a civilization trillions of years from now. You look into the heavens. Instead of seeing billions of galaxies, you might see only one enormous merged galaxy containing the remnants of many smaller ones. The Milky Way and the nearby Andromeda galaxy are expected to merge billions of years from now. Other nearby galaxies may join them over immense spans of time. The result could be a giant galactic island floating alone in apparent darkness. Future astronomers living there might conclude that their galaxy is the entire universe, and based on the evidence available to them, that conclusion could seem perfectly reasonable. The distant galaxies that revealed cosmic expansion to us today would no longer be visible. The clues would be gone. It is a strange thought. Humanity often assumes science progresses because knowledge accumulates, but science also depends on access to evidence. Remove enough evidence, and some truths become almost impossible to discover. This means our position in time may be unusually fortunate, not because we are technologically advanced, not because we are special, but because we happen to live during an era when the universe still displays much of its history openly. The cosmic microwave background offers another remarkable example. This ancient glow is often described as the oldest light in the universe. It originated when the cosmos became transparent hundreds of thousands of years after the Big Bang. Today, it surrounds us in every direction. Sensitive instruments can detect it easily. Its tiny temperature variations reveal extraordinary information about the early universe. It is one of the greatest scientific treasures ever discovered. Yet even this ancient light will not remain equally visible forever. As the universe expands, the wavelengths of this radiation continue stretching. Over unimaginable timescales, the signal becomes weaker and harder to detect. Future civilizations may struggle to find it at all. Without the cosmic microwave background, understanding the universe's origins would become far more difficult. Many of the clues we rely upon today would vanish into the darkness of time. It is almost as if the universe is slowly closing chapters of its own story. Not suddenly, not dramatically, but gradually, quietly, relentlessly. And yet there is something strangely beautiful about this process. Because while some evidence disappears, other wonders continue unfolding. Stars are still being born. Galaxies are still evolving. Black holes continue growing. New planetary systems continue forming inside giant clouds of gas and dust. The cosmos remains alive with change. We simply happen to occupy a moment when both the ancient past and the active present remain visible together. That combination may be rare, perhaps extraordinarily rare. Right now, you can look into the night sky and see stars whose light began traveling before human civilization existed. With powerful telescopes, we can observe galaxies whose light began its journey billions of years ago. We can witness the universe at many ages simultaneously. The sky becomes a collection of different eras layered together. Nearby stars show the recent universe. Distant galaxies reveal the ancient universe. The oldest light reveals the young universe. All of these chapters remain available at once. That may not always be true. The future cosmos could become increasingly isolated, more silent, more difficult to interpret. Yet tonight, the universe still shares its memories. The evidence remains scattered across the sky, like pages from an enormous cosmic archive. And perhaps that is what makes our era so extraordinary. Not that we know all the answers. Far from it. Many mysteries remain unsolved. Dark matter, dark energy, the nature of cosmic origins, the ultimate fate of reality itself. But we live during a time when the questions can still be asked, because the clues still exist. The universe continues revealing enough of its story for curious minds to follow its trail. As you drift deeper into relaxation tonight, imagine the countless generations of stars that came before us. Imagine the galaxies shining across unimaginable distances. Imagine ancient photons finally arriving after journeys lasting billions of years. And imagine how fortunate it is that those messages are reaching us now. Because in the grand timeline of the cosmos, this moment may be one of the few when so much of the universe remains visible all at once. A brief chapter, a luminous chapter. A chapter in which the cosmos still remembers enough of its past to tell us where we came from. And for now, beneath this quiet night sky, those ancient stories are still being told. 3. Gravity is secretly shaping everything around you. Gravity is so familiar that most of us rarely think about it. You feel it every moment of your life. It keeps your feet on the ground. It guides falling rain toward the earth. It pulls oceans into tides. It gives weight to every object around you. And because it is always present, gravity can seem almost ordinary. Yet gravity is anything but ordinary. In many ways, it is one of the most mysterious forces in the universe. Tonight, as you rest quietly beneath the stars, gravity is doing far more than holding you gently against the surface of our planet. It is guiding the moon around Earth. It is steering Earth around the sun. It is holding together hundreds of billions of stars inside the Milky Way. It is shaping giant clusters of galaxies across millions of light years. It is bending light itself. And on the largest scales imaginable, gravity is helping determine the future evolution of the cosmos. Perhaps the strangest part is that gravity remains invisible. You cannot see it, you cannot touch it, you cannot hear it. You only witness its effects. And yet, those effects are everywhere. In a sense, gravity is like a hidden architect, quietly working behind the scenes of reality. Most of the structures we observe throughout the universe exist because gravity spent billions of years patiently building them. Without gravity, the universe would be almost unrecognizable. After the Big Bang, matter was distributed throughout space in a remarkably smooth way. Tiny fluctuations existed, but overall, the young universe was surprisingly uniform. Left alone, that matter might have remained a diffuse cloud forever. But gravity changed everything. Over immense spans of time, slightly denser regions attracted additional matter. Those regions became denser still. Small differences slowly grew larger. Gradually, enormous clouds of gas formed. Stars ignited. Galaxies assembled. Clusters emerged. The vast cosmic web began taking shape. Every galaxy you see in astronomical photographs is ultimately a monument to gravity's patience. Unlike explosions or collisions, gravity often works slowly, sometimes unimaginably slowly. It can spend hundreds of millions of years creating changes that appear almost instantaneous when viewed across cosmic history. Gravity is not a force of hurry. It is a force of persistence. And persistence, given enough time, can reshape entire universes. Imagine watching a single snowflake land on a mountain. The event seems insignificant, yet countless snowflakes over centuries can alter entire landscapes. Gravity works in a similar way. Its influence accumulates. It never stops. It never becomes tired. And over billions of years, its quiet work becomes impossible to ignore. One of the most beautiful examples can be found inside giant molecular clouds. These enormous regions of gas drift through galaxies like cosmic fog banks. Some contain enough material to create thousands of stars. At first glance, they appear peaceful and stable. Yet gravity is constantly at work within them. Tiny regions become slightly denser than their surroundings. Once that happens, gravity strengthens its grip. More gas falls inward. Density increases further. Temperatures rise. Eventually, a newborn star ignites. A new sun begins shining. Every star in the night sky owes its existence to this process, including our own sun. Long before Earth existed, gravity slowly gathered gas inside an ancient cloud. That cloud collapsed, pressure increased, fusion began, and the star that would one day warm our planet was born. Without gravity, there would be no sunrise, no oceans, no atmosphere, no life. Gravity literally made our existence possible. Yet gravity's influence extends far beyond stars. It also governs entire galaxies. The Milky Way contains hundreds of billions of stars. Each star moves through space under gravity's guidance. The galaxy is not a static object. It rotates. Stars orbit its center. Gas flows through spiral arms. Dark matter forms a massive invisible halo surrounding it. Everything remains organized because gravity continuously holds the system together. If gravity suddenly vanished, the galaxy would fly apart. Stars would drift into intergalactic space. Planetary systems would unravel. Structure would dissolve into chaos. Fortunately, gravity never lets go. It quietly maintains order throughout the cosmos. Perhaps even more remarkable is gravity's ability to influence light itself. For centuries, people assumed light traveled in perfectly straight lines. Then came one of the greatest scientific revolutions in history. Albert Einstein proposed something extraordinary. Gravity, he suggested, is not simply a force pulling objects together. Instead, gravity is the curvature of space and time. Massive objects warp the fabric of space-time around them. Planets follow those curves. Stars follow those curves. Even light follows those curves. Imagine placing a heavy ball onto a stretched sheet. The surface bends. Smaller objects rolling nearby naturally move along the distorted surface. While the analogy is imperfect, it helps illustrate Einstein's insight. Mass changes the geometry of reality itself. And when light passes near something extremely massive, its path bends. Today, astronomers regularly observe this phenomenon. Entire galaxies act like giant lenses. Their gravity bends light from even more distant galaxies behind them. The result creates beautiful arcs, rings, and distorted images across the sky. This phenomenon is known as gravitational lensing, and it allows scientists to study regions of the universe that would otherwise remain hidden. In a very real sense, gravity can act like a cosmic telescope, using nothing but the curvature of space-time. Gravity also reveals things we cannot see directly. Dark matter remains one of the greatest mysteries in modern science. It appears invisible. It does not emit light. It does not reflect light. It does not glow. Yet astronomers know it exists because of gravity. Galaxies rotate too quickly to be held together by visible matter alone. Clusters of galaxies contain more gravitational pull than ordinary matter can explain. Gravitational lensing reveals invisible mass throughout the cosmos. Again and again, gravity exposes the presence of something hidden. It acts almost like a detective, revealing clues that would otherwise remain unnoticed. In fact, much of what we know about dark matter comes not from seeing it directly, but from observing gravity's fingerprints. The invisible force helps reveal invisible matter. And then there are black holes, perhaps gravity's most dramatic creations. A black hole forms when gravity becomes overwhelmingly powerful. Matter collapses inward so completely that not even light can escape. The result is an object where space-time itself becomes profoundly distorted. Near a black hole, gravity behaves in ways that challenge ordinary intuition. Time slows, light bends dramatically, distances become difficult to interpret. Yet even here, gravity follows the same fundamental principles that guide a falling leaf or orbiting planet. The difference is merely one of scale. The same force holding you gently to Earth is capable of creating some of the most extreme environments in existence. That realization can feel almost impossible to grasp. The gravity you experience every day and the gravity near a supermassive black hole are expressions of the same underlying phenomenon. From the smallest human experience to the largest cosmic structures, gravity connects everything, and its story may be even deeper. Today, scientists still struggle to unite gravity with quantum physics. The theory that describes the very small and the theory that describes the very large do not yet fit together perfectly. Some of the greatest minds in science continue searching for answers. What exactly is gravity? Why does it exist? How does it truly behave at the deepest levels of reality? No one knows completely, and perhaps that uncertainty makes gravity even more fascinating. The force that seems most familiar may still hide profound secrets. Tonight, while you rest beneath the stars, gravity continues its endless work. It guides the planets, it shapes the galaxies, it bends the paths of ancient light crossing billions of light years. It gathers clouds that will become future stars. It holds together the structures of the visible universe. Quietly, patiently, without ever demanding attention. Gravity has been shaping the cosmos for more than 13 billion years. And even now, as your breathing grows slower and your thoughts become lighter, this invisible architect continues building the universe around you, one gentle pull at a time. If you're enjoying tonight's gentle journey through the hidden forces of the cosmos, consider subscribing and joining us for more peaceful explorations beneath the stars. 4. Most stars in the universe may never host life. At first, the idea sounds almost impossible. How could a universe so vast, so unimaginably filled with stars, fail to produce life almost everywhere? After all, when we look up at the night sky, we see only a tiny fraction of what actually exists. The Milky Way alone contains hundreds of billions of stars. Beyond it lie hundreds of billions of galaxies. Together, the total number of stars may exceed the number of grains of sand on every beach on Earth. Surely, among such staggering abundance, life must be common. And perhaps it is. But there is another possibility that quietly emerges when astronomers study the requirements for life as we know it. Many stars may never provide suitable homes at all. In fact, most stars in the universe may be permanently hostile to the kind of biology that eventually appeared on Earth. Tonight, as you rest beneath the stars, it is worth remembering how unusual our own situation may be. Not because Earth is necessarily unique, not because life is necessarily rare, but because creating a stable environment for life appears far more complicated than simply having a star. The universe is full of stars, yet not all stars are equal. Some are born too massive, some die too quickly, some unleash violent radiation, some exist in unstable systems, some may never allow planets to form properly, and many may simply never provide enough time for complex life to emerge. The story begins with the lifespan of stars. Our sun is often described as ordinary. Astronomers call it a yellow dwarf. Among the countless stars in the cosmos, it is not especially large, bright, or unusual. And that may actually be one of its greatest strengths. The sun burns steadily. It changes slowly. Its lifetime spans billions of years. This gives life something incredibly valuable: time. Life on Earth did not appear overnight. The first simple organisms emerged billions of years ago. Complex animals arrived much later. Human civilization occupies only a tiny fraction of Earth's history. If our star had burned for only a few million years, none of this would have happened. There simply would not have been enough time. And many stars face exactly that problem. The largest stars in the universe live astonishingly short lives. Some contain dozens or even hundreds of times the sun's mass. They shine with incredible brilliance. Their light can outshine millions of ordinary stars. But they pay a price for that power. They consume their fuel with extraordinary speed. Some survive only a few million years before exploding. From a cosmic perspective, that is barely an instant. A planet orbiting such a star would face a difficult challenge. Life would need to emerge, evolve, and become complex before the star died. That may be asking far too much. The most spectacular stars in the universe may therefore be among the least hospitable. They are beautiful, they are powerful, but they are impatient. Life appears to require patience. On the opposite end of the spectrum are red dwarf stars. These tiny stars are actually the most common stars in the universe. They may account for the majority of all stars that exist. Unlike giant stars, red dwarfs live extraordinarily long lives. Some could continue shining for trillions of years. That sounds promising. After all, abundant time seems beneficial for life. Yet red dwarfs bring their own difficulties. Many are highly active during their youth. They produce powerful stellar flares. Radiation storms can erupt frequently. Nearby planets may endure repeated bombardment from energetic particles. Atmospheres could be stripped away. Surface conditions could become unstable. Some red dwarf planets may survive these challenges. Others may not. Scientists continue debating exactly how friendly red dwarf systems might be. The answer remains uncertain, but the question itself reveals something important. Not every long-lived star automatically becomes a cradle for life. A star must provide more than longevity. It must provide stability, and stability may be surprisingly rare. Then there's the issue of planetary orbits. Even if a suitable star exists, planets must occupy the right locations. Too close and oceans evaporate. Too far and water freezes. Astronomers often refer to this region as the habitable zone. It is sometimes called the Goldilocks zone because conditions are neither too hot nor too cold. But even that phrase can be misleading. Life depends on much more than distance. Planetary atmospheres matter, magnetic fields matter, geology matters, chemical composition matters. The presence of water matters. A planet can sit inside the habitable zone and still be completely lifeless. The universe may contain countless worlds that appear promising at first glance, but ultimately remain barren. And there are additional dangers. Some stars exist in crowded environments. Near the centers of galaxies, stars can be packed closely together. Gravitational disturbances become more common. Nearby supernova explosions may occur. Radiation levels can rise dramatically. Planetary systems may experience instability over long timescales. Life requires not only favorable conditions, but also protection from cosmic chaos. Earth has been fortunate. Our solar system occupies a relatively calm region of the Milky Way. We are not too close to the galactic center. We are not trapped inside a dense stellar cluster. We exist in a location where catastrophic events appear infrequent enough to allow billions of years of biological evolution. That balance may not exist everywhere. The universe often seems indifferent to life. Black holes consume matter without concern. Stars explode, galaxies collide. Radiation floods through space. Most cosmic processes occur without any regard for biology. Life appears to thrive only within relatively narrow windows of stability, and those windows may represent only a small fraction of all possible environments. Perhaps the strangest realization comes when we think about time. The universe itself has not always been friendly to life. The earliest stars contained almost no heavy elements. Rocky planets require elements such as carbon, oxygen, silicon, magnesium, and iron. These materials did not exist in significant amounts immediately after the Big Bang. They had to be forged inside stars. Early generations of stars created them. Supernova explosions scattered them into space. Later generations of stars inherited richer chemical ingredients. In a sense, the universe needed time to become capable of producing Earth-like planets. Life could not emerge immediately. The cosmos first had to manufacture the necessary raw materials. Even today, that process continues. New stars are still forming. New planetary systems continue appearing. Future worlds may arise billions of years from now. Some may host life long after Earth is gone. Yet many stars will never participate in that story. They will burn their fuel and fade without ever supporting living worlds. Not because life is impossible, but because the conditions were never right. This realization changes how we view the night sky. Each star becomes more than a point of light. Each star represents a possibility. Some possibilities may lead to barren planets. Some may lead to oceans and atmospheres. Some may lead to simple microbes. Some may eventually produce civilizations that gaze upward and wonder about their place in the cosmos. And many may never host life at all. The universe does not distribute opportunity equally. It creates countless stars, but only some may provide the delicate combination of stability, chemistry, time, and environment that life seems to require. Yet perhaps that makes our existence even more remarkable. Not miraculous, not necessarily unique, but precious. Because among hundreds of billions of trillions of stars, you happen to live beside one that has remained stable long enough for oceans to form, ecosystems to evolve, and conscious beings to emerge. Tonight, while countless stars shine across the darkness, gravity continues guiding planets through their orbits. New stars continue forming inside distant clouds. Ancient stars continue fading toward their final chapters. And somewhere among this immense population, life may be awakening for the first time. Elsewhere, many stars may remain forever silent. The universe offers endless opportunities, but not every opportunity becomes a home. And as you drift deeper into rest tonight, perhaps there is something comforting in that thought. Among all the stars that may never host life, one small yellow star did. And because of that, you are here now, quietly observing the cosmos that made your existence possible. 5. The night sky used to look completely different. Look up at the night sky for a moment. Imagine the familiar patterns that humans have recognized for thousands of years. The hunter of Orion, the curve of the Big Dipper, the bright stars of Scorpius, the steady glow of Polaris marking the northern sky. These patterns feel permanent. Ancient civilizations saw many of the same constellations we see today. Generations have passed their stories down through countless centuries. The stars seem fixed, reliable, unchanging. Yet this impression is one of the greatest illusions created by the vast scales of the universe. The truth is far stranger. The night sky is not permanent at all. It is changing continuously, slowly, silently, relentlessly. And if you could travel billions of years into the past, the sky above Earth would be almost completely unrecognizable. The constellations we know would not exist. Many familiar stars would not yet have formed. Others would occupy entirely different positions. Some would not even belong to the Milky Way yet. Tonight, as you rest beneath the darkness, you are looking at a temporary arrangement of stars, a cosmic snapshot, one brief frame in a much longer movie. And like every frame in that movie, it will eventually disappear. The reason begins with something surprisingly simple. Stars move. When we gaze upward, the stars appear fixed because human lives are short. A century feels long to us. 1,000 years seems ancient. But stars operate on timescales far beyond ordinary experience. Every star in the Milky Way is traveling through space, including our sun. Each follows its own orbit around the center of the galaxy. Each possesses its own speed, its own direction, its own history. Over a single night, the motion is invisible. Over a lifetime, it remains nearly impossible to notice. But over millions of years, the changes become dramatic. Imagine freezing the night sky today, then advancing time forward 10 million years. Many familiar constellations would become distorted. Some stars would drift apart, others would move closer together. New patterns would emerge, old ones would vanish. The sky would still contain stars, but it would no longer tell the same visual story. Constellations are not permanent structures. They are temporary alignments, accidents of perspective. They exist only because Earth happens to occupy a particular location at a particular moment in cosmic history. This becomes even more remarkable when we consider Orion. Today, Orion is one of the most recognizable constellations on Earth. Its bright stars form a shape that has inspired myths across countless cultures. Yet Orion itself is fragile. The stars that compose it are not traveling together as a single group. They occupy different distances from Earth. They move independently. Given enough time, the hunter will slowly dissolve. Millions of years from now, future observers may struggle to recognize it at all. The same is true for nearly every constellation we know. The night sky feels timeless, but it is actually fluid, changing shape with every passing age. Traveling backward through time reveals even more dramatic transformations. If you could visit Earth 1 billion years ago, many stars visible today would still exist. Yet the sky would already appear different. The positions of constellations would be altered. The Milky Way would stretch differently across the heavens. Nearby stellar neighborhoods would have shifted. But continue traveling farther into the past and the changes become profound. 2 billion years, 3 billion years, 4 billion years. At some point, familiar landmarks begin disappearing entirely. Many stars that dominate our sky today had not yet been born. Massive clouds of gas still drifted through space, waiting for gravity to gather them together. Future suns remained hidden inside dark nebulae. The universe was preparing them, but they had not yet ignited. This means the night sky of ancient Earth was not simply a rearranged version of today's sky. In many places, it was illuminated by entirely different stars, different stellar populations, different cosmic neighbors, different stories. Perhaps even more astonishing is the fact that our galaxy itself has changed enormously. The Milky Way is not frozen. It evolves. Stars form, stars die. Spiral arms shift. Gas clouds migrate. Entire regions transform over billions of years. When Earth first formed roughly 4.5 billion years ago, the Milky Way looked different from the galaxy we inhabit today. Not completely alien, but noticeably younger. Some stellar clusters had not formed. Others still existed that have since dispersed. The galaxy itself was participating in an ongoing process of growth and change. And this process continues even now. Every year, new stars are born somewhere within the Milky Way. At the same time, other stars exhaust their fuel. Some quietly fade into white dwarfs. Others explode as supernovae. The night sky is constantly renewing itself. We simply observe too slowly to notice. There is another reason the ancient sky would appear unfamiliar. The sun itself occupies a different position within the galaxy over time. Our solar system orbits the center of the Milky Way at extraordinary speed, roughly 230 kilometers per second. That is fast enough to travel from New York to Los Angeles in less than 20 seconds. Yet because the galaxy is so enormous, a complete orbit requires around 225 million years. Astronomers sometimes call this a cosmic year. Since Earth formed, the solar system has completed only about 20 galactic orbits, 20 journeys around the Milky Way. That means Earth has repeatedly traveled through entirely different regions of the galaxy, different stellar environments, different cosmic scenery, different neighborhoods of stars. The sky seen by ancient dinosaurs was not exactly the same sky visible to humans today, and the sky visible to future civilizations will be different still. The universe never stands still long enough to preserve a single view forever. Then there are the stars that no longer exist. Some of the brightest stars visible in Earth's distant past have already vanished. Massive stars live short lives. A few million years can be enough to carry them from birth to destruction. Some exploded long before humans appeared. Others disappeared before mammals evolved. Ancient Earth may have been illuminated by brilliant stars that left no modern descendants. Imagine looking upward and seeing celestial landmarks that have been absent for hundreds of millions of years. Entire constellations may have contained stars now completely gone. Their light once shaped the appearance of the heavens. Today, only their remnants remain. Neutron stars, black holes, expanding clouds of gas, ghosts of former suns. The sky remembers them only indirectly. And future skies will experience similar losses. Some stars that dominate our current night sky are already approaching the ends of their lives. Not immediately, not tomorrow, but eventually. Even the most familiar celestial companions are temporary. One day, they too will disappear. Perhaps the most breathtaking transformation of all awaits billions of years in the future. The Milky Way and the neighboring galaxy Andromeda are moving toward one another right now. Gravity is slowly drawing them together. The collision will take billions of years to unfold, but when it happens, the night sky of future Earth, or whatever remains of Earth, will become spectacular beyond imagination. Andromeda will gradually grow larger, brighter, more detailed. Eventually, it will dominate huge portions of the sky. Stars from both galaxies will intermingle. New bursts of star formation may occur. The heavens will become dramatically different from anything humans have ever known. Future observers may inherit a sky so transformed that our present constellations seem as ancient and mysterious as prehistoric fossils. The night sky, it turns out, is not a permanent ceiling above our heads. It is a living record of cosmic evolution, a temporary arrangement created by motion, gravity, and time. Every star is traveling. Every constellation is changing. Every galaxy is evolving. And every moment produces a slightly different version of the universe. Tonight, the stars above you appear calm and eternal. They seem fixed in their places. They seem destined to remain forever. But the universe tells a different story. The heavens are changing even now, slowly enough to escape human notice, yet steadily enough to reshape entire skies across cosmic ages. And perhaps there is something comforting about that. The beauty above us is not permanent. It never was. Its value comes partly from its impermanence. We happen to exist during one brief chapter of the universe's story. One moment when these particular stars form these particular patterns. One moment when Orion still stands in the sky. One moment when the Milky Way stretches overhead exactly as it does tonight. And as your thoughts drift gently toward rest, imagine the countless skies that came before ours. The forgotten constellations seen by ancient Earth. The vanished stars that once illuminated the darkness. The future heavens that no human eyes will ever witness. All of them part of the same endless cosmic story. A story written not in words, but in starlight slowly changing across the ages. 6. Time moves differently across the universe. At first, the idea sounds impossible. Time feels constant. A second is a second. A minute is a minute. Whether you are lying quietly beneath the stars, walking across a city street, or traveling through the depths of space, time appears to flow at the same steady pace. It feels universal, reliable, absolute. For most of human history, that assumption seemed perfectly reasonable. Time appeared to be the one thing everyone shared equally. But the universe has a way of surprising us. And among its most astonishing discoveries is this: time itself is not fixed. It can stretch. It can slow down. It can flow at different rates depending on where you are and how you move. In some parts of the cosmos, time behaves so strangely that what feels like a few hours for one observer could correspond to years for another. Entire futures can unfold while someone experiences only a fraction of that passage. And the deeper scientists explored gravity, space, and motion, the more they realized that time is not the rigid cosmic clock we once imagined. Instead, it is woven into the very fabric of reality itself. Tonight, as you relax beneath the darkness, we are going to explore one of the strangest truths ever discovered. A truth that sounds like science fiction, yet appears to be built directly into the structure of the universe. The story begins with a simple question: what exactly is time? That may sound obvious. We measure it every day. Clocks tick, calendars advance, days become years. Yet defining time turns out to be surprisingly difficult. We experience it constantly, but we cannot touch it. We cannot hold it. We cannot see it directly. Instead, we observe change: a heartbeat, a sunrise, the motion of planets, the aging of stars. Time reveals itself through transformation. Without change, time would become impossible to notice. For centuries, scientists assumed that time flowed uniformly everywhere. Isaac Newton imagined a cosmic clock ticking identically throughout the universe. Whether someone stood on Earth or floated among distant stars, time itself was thought to remain unchanged. Then came one of the greatest revolutions in scientific history. A young physicist named Albert Einstein began questioning assumptions that most people accepted without hesitation. His ideas would eventually transform our understanding of reality. And among those ideas was a realization that seemed almost unbelievable. Time depends on motion. Imagine two identical clocks. One remains on Earth. The other travels through space at enormous speed. Common sense suggests both clocks should remain synchronized. Yet according to Einstein's theory of relativity, they do not. The moving clock runs slightly slower, not because it is broken, not because it functions differently, but because time itself is flowing differently for the traveler. This phenomenon is known as time dilation, and remarkably, it is not merely theoretical. It has been measured repeatedly. Highly accurate atomic clocks carried aboard aircraft return, showing tiny differences compared to clocks that remained on Earth. Satellites orbiting our planet experience time differently than observers on the ground. Even the GPS system guiding navigation around the world must account for these effects. Without corrections from relativity, GPS positions would drift by kilometers every day. The technology in your pocket works partly because Einstein was right. Time truly does flow differently under different conditions. But motion is only part of the story. Gravity also affects time. This may be even stranger. Imagine standing at the edge of a deep valley. Now imagine another observer standing atop a mountain. According to relativity, time passes very slightly faster for the observer on the mountain. The difference is tiny, far too small to notice without extremely precise instruments. Yet it exists. Gravity slows time. The stronger the gravitational field, the slower time flows. This means that every object in the universe influences the passage of time around it. Planets, stars, galaxies, black holes, all shape time itself. The effect becomes dramatic near the most extreme objects in existence. Black holes. These mysterious objects possess gravity so powerful that not even light can escape once it crosses a boundary known as the event horizon. Near a black hole, time behaves in ways that challenge human intuition. To a distant observer, a clock near the black hole appears to slow dramatically. Minutes become hours, hours become days. Time stretches. The closer the clock approaches the event horizon, the more extreme the effect becomes. In theory, near the very edge, time could appear almost frozen from an outside perspective. Meanwhile, the observer carrying the clock would experience nothing unusual. Their heartbeat continues normally, their thoughts continue normally. Their local experience feels unchanged. Yet compared with the distant universe, their time is passing far more slowly. This creates one of the strangest consequences in physics. Two observers can disagree about the passage of time, and both can be correct. Perhaps the most famous example appears in the so-called twin paradox. Imagine identical twins. One remains on Earth, the other travels through space at speeds approaching the speed of light. After many years, the traveler returns. Something remarkable happens. The traveling twin has aged less. Not metaphorically, not psychologically, physically. Their biological clock has experienced less time. Their cells have undergone fewer years of aging. Meanwhile, the twin on Earth has grown older. The difference could be small, or under extreme circumstances, enormous. Future interstellar travelers might someday experience this directly. A voyage lasting only a few years for astronauts could correspond to decades or centuries passing on Earth. The travelers would return to a future they never fully lived through. The universe permits such possibilities, not through magic, but through the geometry of space and time. And then we arrive at one of the most beautiful ideas in modern physics. Space and time are not separate things. They form a single entity, a four-dimensional structure known as space-time. Mass and energy distort this structure. Planets curve it, stars curve it, galaxies curve it, black holes curve it dramatically. Objects move through these curves. Light follows these curves. Even time follows these curves. The universe resembles a vast cosmic landscape where geometry governs reality itself. We often imagine gravity as a force pulling objects together. Einstein offered a deeper picture. Mass tells space-time how to curve. Space-time tells matter how to move, and time is woven directly into that relationship. The result is a cosmos far stranger than earlier generations ever imagined. A cosmos where time is flexible, dynamic, responsive. A cosmos where every clock experiences reality slightly differently. Even now, while you lie quietly beneath the night sky, this phenomenon surrounds you. Time moves a little faster aboard satellites than it does on Earth's surface. Time moves a little slower near Earth's center than near its atmosphere. The differences are tiny, yet they are real. The universe is constantly adjusting the flow of time everywhere. Most of the changes are far too subtle for human awareness. but on cosmic scales, they become profound. Near neutron stars, near black holes, across billions of light years, time itself becomes part of the landscape. And perhaps that realization changes how we think about existence. We often imagine ourselves moving through time. Yet in another sense, time moves differently around us depending on where we are in the universe. The cosmos is not governed by one universal clock. Instead, countless clocks tick throughout reality, each following its own path through space-time, each experiencing its own version of duration. And still, despite all this complexity, life unfolds. Stars are born, galaxies collide, planets orbit, civilizations emerge, all while time quietly bends and stretches behind the scenes. Tonight, as your thoughts grow calmer and your breathing becomes slower, imagine the countless clocks scattered across the universe. A clock orbiting a distant neutron star, a clock drifting between galaxies, a clock approaching the edge of a black hole, each measuring time differently, each experiencing reality through its own unique journey, yet all belonging to the same vast cosmos. A universe where time is not merely something that passes, it is something that lives within the very fabric of existence itself. And as you drift towards sleep, perhaps there is something comforting in that thought. The universe is stranger than we once believed, far stranger, yet also more beautiful, because even time itself is part of the endless mystery unfolding among the stars. 7. Entire oceans may exist beneath frozen worlds. Now imagine a world completely locked in ice. No blue oceans glimmer beneath sunlight. No green continents stretch across the horizon. No gentle waves break against a shoreline. From space, such a world might appear lifeless, frozen, silent, dead. For a long time, scientists assumed that liquid water, and therefore life, required warmth from a nearby star. A planet needed to sit within a comfortable, habitable zone, not too hot, not too cold, just the right distance from its sun. Yet the deeper we explored our own solar system, the stranger reality became, because some of the most intriguing places where life might exist are not warm worlds at all. They are frozen worlds, dark worlds, worlds hidden beneath enormous shells of ice. And beneath those frozen surfaces may lie entire oceans larger than all the oceans on Earth combined. Vast alien seas concealed from direct view, quietly existing in darkness for billions of years. Tonight, as you rest beneath the stars, let us journey into these hidden oceans. Because some of the universe's most promising habitats may not be found beneath open skies. They may exist deep beneath frozen crusts, where sunlight has never reached. The first clues emerge surprisingly close to home. One of the most fascinating examples is Jupiter's moon, Europa. At first glance, Europa appears simple, a bright sphere covered almost entirely by ice. Its surface is remarkably smooth compared to many other moons. Cracks stretch across the landscape like giant scars. Long, dark lines intersect one another across thousands of kilometers. There are few mountains, few craters, few obvious signs of activity. Yet beneath that icy shell, scientists believe something extraordinary exists: a global ocean. Not a small sea, not a collection of underground lakes. An ocean that may contain more water than all of Earth's oceans combined. Imagine that for a moment. Beneath a frozen crust, perhaps many kilometers thick, lies an entire world of liquid water, a hidden, planet-sized sea. The obvious question follows immediately. How can liquid water survive so far from the sun? Jupiter receives only a fraction of the sunlight reaching Earth. Europa's surface temperatures plunge far below freezing. If sunlight were the only heat source available, the ocean should have frozen solid long ago. The answer comes from gravity. Europa does not orbit Jupiter in a perfectly simple way. The immense gravitational pull of Jupiter constantly stretches and squeezes the moon. As Europa travels through its orbit, its shape changes slightly. The entire moon flexes. Tiny distortions occur again and again. These movements generate internal heat. The process is known as tidal heating, and over billions of years, that heating may have been sufficient to keep vast quantities of water liquid beneath the ice. In a sense, Europa is warmed from within. Its ocean survives not because of sunlight, but because gravity itself acts as a hidden energy source. This realization transformed scientific thinking. For generations, habitable environments were associated primarily with Earth-like planets orbiting stars. Europa suggested another possibility. Life might survive in places completely isolated from sunlight. Life might not need a bright sky at all. The idea became even more fascinating when scientists looked at Earth's own oceans. Deep beneath our seas, near hydrothermal vents, entire ecosystems flourish in total darkness. These environments exist thousands of meters below the surface. No sunlight reaches them, yet life thrives. Bacteria extract energy from chemicals emerging from the seafloor. Complex communities form around these energy sources. Strange creatures survive in conditions once thought impossible. This discovery changed everything. Because if life can survive without sunlight on Earth, perhaps it could survive beneath Europa's ice as well. Perhaps somewhere within that hidden ocean, microscopic organisms drift through the darkness. Perhaps chemical reactions near the seafloor provide energy. Perhaps ecosystems have existed there for millions or even billions of years. No one knows. But the possibility is difficult to ignore, and Europa is not alone. Farther from the Sun lies Saturn's moon Enceladus. At first glance, Enceladus seems even less promising. It is small, cold, brilliantly white, a frozen world only a fraction the size of Earth. Yet when spacecraft visited the moon, they discovered something astonishing. Giant plumes of water vapor erupting into space. These geysers shoot through cracks in the ice near the South Pole. They release water, ice particles, organic molecules, and other materials from deep below the surface. It is as though Enceladus is revealing pieces of its hidden interior to the cosmos. Scientists studying these plumes found evidence suggesting a liquid ocean beneath the ice. Not only that, the ocean appears to interact with a rocky seafloor. This is important because such interactions can generate chemical energy, the same kind of energy that supports life near Earth's hydrothermal vents. Suddenly, Enceladus became one of the most exciting places in the solar system, a tiny frozen moon, yet potentially one of the best locations to search for alien life. And perhaps the most remarkable aspect of all is this: neither Europa nor Enceladus lies within the traditional habitable zone. According to older ideas, both worlds should be far too cold, far too hostile, far too frozen. Yet hidden oceans may have existed beneath their surfaces for immense periods of time. The universe continues reminding us that life may be more adaptable than we once imagined. The deeper scientists looked, the more hidden oceans they found. Evidence suggests that several moons throughout the solar system may contain subsurface seas. Saturn's moon Titan, Jupiter's moon Ganymede, possibly Callisto, perhaps others still undiscovered. Entire aquatic worlds concealed beneath ice. Some may have existed longer than Earth's modern oceans. Some may continue evolving today. And this raises a profound possibility. If hidden oceans are common in our solar system, perhaps they are common throughout the galaxy as well. After all, moons are abundant. Ice is abundant. Water appears surprisingly abundant. The ingredients required for these hidden environments may be widespread across the cosmos. Perhaps countless frozen worlds orbit distant stars. Perhaps beneath their icy shells, oceans quietly endure, dark, silent, invisible from afar, yet potentially alive. In fact, some scientists now wonder whether subsurface oceans could outnumber Earth-like environments across the galaxy. A frozen ocean world does not require the precise conditions demanded by a temperate planet. It does not need mild weather. It does not need open seas beneath sunlight. It only requires liquid water, energy, and time. And the universe appears capable of providing all three. Imagine drifting through one of these alien oceans. Above you, kilometers of solid ice block all sunlight. No dawn ever arrives. No sunset ever occurs. The sky does not exist. Yet beneath the darkness, warm currents move slowly through the water. Minerals rise from the seafloor. Chemical reactions unfold continuously. An entire hidden world operates beyond sight. If life exists there, it may never know what stars look like. It may never understand the concept of a night sky. Its entire universe could be contained within an endless ocean beneath ice. A civilization arising in such a place might not even realize it lives on a moon orbiting a planet around a star. The cosmos beyond the ice could remain forever hidden. And perhaps that is one of the most beautiful ideas in modern astronomy. The universe may contain countless forms of existence, unfolding in places we once overlooked entirely. Not beneath warm sunlight, not on Earth-like worlds, but beneath frozen crusts drifting through darkness. Entire oceans hidden from view, entire ecosystems waiting to be discovered. Entire stories unfolding silently beneath alien ice. And tonight, as you allow your thoughts to drift gently towards sleep, imagine those distant oceans. Ancient waters moving beneath frozen worlds, hidden currents flowing through eternal darkness, possible life forms drifting beneath ceilings of ice, entire unseen realms quietly existing far beyond Earth. The stars above may capture our attention, but some of the greatest mysteries in the cosmos may be hidden far below the surface, waiting patiently beneath frozen worlds where sunlight has never shone. 8. The atoms in your body have traveled for billions of years. The atoms inside your body are older than mountains, older than oceans, older than Earth itself. And in a very real sense, they are older than the sun. Tonight, as you rest beneath the quiet darkness, it is worth remembering that every atom around you carries a history so vast that it stretches across billions of years of cosmic time. The calcium in your bones, the iron in your blood, the oxygen you breathe, the carbon woven into every living cell. None of these elements were present when the universe first began. In the earliest moments after the Big Bang, the cosmos was astonishingly simple. There were no planets, no trees, no oceans, no people. There were not even stars. The young universe contained mostly hydrogen and helium, along with tiny traces of lithium. That was almost everything. The heavier elements required for life simply did not exist yet. And this raises a fascinating question. If the early universe contained almost nothing but hydrogen and helium, where did the atoms inside your body come from? The answer takes us deep into one of the greatest stories ever told by science, a story that begins inside stars. After the first stars formed, gravity compressed enormous clouds of hydrogen gas until their cores became unimaginably hot. Temperatures rose to millions of degrees. At those extreme conditions, atomic nuclei began to fuse together. Hydrogen became helium. Helium eventually helped create heavier elements. Inside these stellar furnaces, the universe began manufacturing entirely new forms of matter. For the first time, nature started building the ingredients that would someday become planets, oceans, and living creatures. Stars became cosmic factories, silent creators working in darkness. And for millions or billions of years, they continued forging new elements deep within their glowing interiors. Yet even stars have limits. A star can only create heavier elements up to a certain point before its own gravity begins winning the battle. Eventually, many stars reach the end of their lives, and when some of the largest stars die, something extraordinary happens. They explode. These explosions, known as supernovae, are among the most powerful events in the universe. For a brief moment, a single dying star can outshine an entire galaxy. The energy released is so immense that it creates elements too heavy to form during the star's normal lifetime: gold, silver, uranium, and many of the atoms required for rocky planets. The explosion then scatters these newly forged elements across space. What was once locked inside a star is suddenly released into the galaxy. Clouds of enriched gas begin drifting outward. Over time, those clouds mix with other material. They spread across enormous distances, and eventually they become the raw ingredients for future generations of stars and planets. In a sense, every supernova is both an ending and a beginning, a death that creates the possibility of countless new worlds. Somewhere in the distant past, long before our solar system existed, many stars lived and died this way. They forged heavy elements, they exploded, and they seeded a region of the Milky Way with material that would eventually become our cosmic neighborhood. About 6 billion years ago, one particular cloud of gas and dust began collapsing under gravity. At its center, the sun was born. Around it, smaller pieces of material gradually gathered together. Some became planets, some became moons, some became asteroids, and one small rocky world became Earth. But Earth was not made from fresh material. Its atoms already carried ancient histories. The carbon embedded in early rocks, the oxygen trapped in minerals, the iron hidden deep within Earth's core. All of it came from stars that had lived and died long before our sun ever appeared. The planet itself was assembled from recycled cosmic matter, and so were you. Every atom in your body has participated in an unimaginably long journey. The iron in your blood may once have existed inside a massive star orbiting the Milky Way billions of years before Earth formed. The oxygen you inhale tonight may have traveled through interstellar clouds before becoming part of our atmosphere. The calcium in your teeth may have been scattered by a supernova explosion that occurred before our solar system existed. These atoms have been part of countless transformations. Stars, nebulae, planets, oceans, living organisms. And now, for a brief chapter in cosmic history, they are part of you. What makes this even more remarkable is that atoms are incredibly durable. Unlike living creatures, atoms do not age in the ordinary sense. They can participate in different structures and different environments, but the atoms themselves often survive. A carbon atom created billions of years ago may still exist today. Its surroundings change, its relationships change, but the atom remains. This means that many of the particles inside your body have experienced a history stretching across much of cosmic time. They have traveled through regions of space that no longer exist in the same form. They have survived the births and deaths of stars. They have witnessed the gradual evolution of galaxies. And somehow, after billions of years of cosmic wandering, they have temporarily gathered together to form a conscious being capable of wondering where they came from. That realization carries a certain quiet beauty, because when people look at the night sky, it is easy to imagine a separation. Us here, the universe out there. Human life on one side, cosmic history on the other. Yet modern astronomy reveals something very different. The boundary is largely an illusion. We are not separate from the universe. We are one of its products, a continuation of processes that began long before Earth existed. The same laws that shape galaxies also shaped the atoms in your body. The same stellar explosions that enriched the Milky Way eventually helped make life possible. The universe did not merely create the conditions for observers. It created observers from its own material. And perhaps that is one of the most profound ideas in all of science. The cosmos became capable of looking back at itself. Tonight, while distant galaxies drift silently through darkness and ancient stars continue their long journeys across the sky, trillions upon trillions of atoms are carrying on their own quiet voyage inside you. They have traveled for billions of years to reach this moment. They will continue traveling long after tonight is over. And although individual lives are brief compared with cosmic time, the atoms themselves will remain part of the universe's unfolding story. A story still being written. A story still moving forward through space and time. And as you settle deeper into rest, perhaps there is something comforting in knowing that you are not merely living in the universe. You are quite literally made from it. The stars did not simply light the cosmos. In a very real sense, they became you. 9. Space is far more empty than you imagine. The emptiness between cosmic objects is so immense that even our most dramatic images of the universe can be slightly misleading. When we look at photographs filled with brilliant stars, glowing nebulae, and crowded galaxies, it is easy to imagine a universe packed with activity. The night sky appears busy. Telescope images seem overflowing with structure. Yet most of reality is not made of stars. Most of reality is made of space. An astonishing amount of space. If every star in the Milky Way were reduced to the size of a grain of sand, the distances between those grains would still be enormous. The universe is not a crowded city. It is more like a vast ocean, where tiny islands are scattered across unimaginable distances. And perhaps one of the strangest facts of all is that almost everything you have ever known exists inside an extraordinarily small oasis, surrounded by overwhelming emptiness. As you rest quietly tonight, It may be comforting to imagine the universe not as a place of constant noise and activity, but as a realm of extraordinary stillness. A stillness so vast that light itself can spend millions or even billions of years crossing it. Inside our own solar system, distances already begin to challenge intuition. Light travels at nearly 300,000 kilometers per second. At that speed, sunlight reaches Earth in about 8 minutes. That feels quick, but even within our solar system, the scale begins to expand dramatically. Light takes over 4 hours to reach Neptune. It takes more than 5 hours to reach the distant dwarf planet Pluto. And beyond Pluto lies a region filled with icy bodies that extends far into darkness. Even there, we have not truly left our cosmic neighborhood. The nearest star beyond the Sun is Proxima Centauri. Its light requires more than 4 years to reach us. Imagine traveling at the speed of a modern passenger jet. Reaching Proxima Centauri would take millions of years. Not thousands, not tens of thousands, millions. And that is merely the closest star. The Milky Way contains hundreds of billions more. The empty regions between them are not small gaps. They are vast cosmic deserts. If the Sun were placed in New York City and reduced to the size of a grapefruit, Earth would become a tiny grain of sand orbiting several meters away. Proxima Centauri would not appear in the next room. It would not even appear in the next city. It would be thousands of kilometers away. Most of the model would consist of empty space. Almost entirely empty space. The stars we admire at night are separated by gulfs so immense that ordinary language struggles to describe them. And yet stars themselves are only the beginning, because galaxies are separated by even greater distances. The Milky Way and the nearby Andromeda Galaxy are slowly moving toward one another through space. Eventually, they will merge in a graceful cosmic encounter. But even though they are approaching each other, the distance between them remains approximately 2.5 million light-years. The light entering your eyes from Andromeda tonight began its journey before the first human ancestors appeared on Earth. That is how much emptiness exists between neighboring galaxies. And beyond Andromeda lie countless others, each surrounded by immense oceans of darkness. Each separated by distances measured not in kilometers or miles, but in millions of years of travel for light itself. When astronomers map the large-scale structure of the universe, they discover something remarkable. Galaxies are not distributed evenly. Instead, they gather into enormous filaments and clusters. These structures form what scientists call the cosmic web. The name sounds intricate and crowded, but even within the cosmic web, emptiness dominates. Between the filaments lie gigantic regions known as cosmic voids. Some voids stretch hundreds of millions of light-years across. Within them, galaxies become extremely rare. A hypothetical traveler drifting through one of these regions might spend tens of millions of years crossing darkness without encountering a major galaxy. These are among the emptiest places known to science, yet they occupy a tremendous fraction of the universe's volume. In a strange way, the cosmic web resembles soap bubbles. The visible structures form delicate boundaries. The vast majority of space exists in the gaps, and those gaps are enormous. The universe seems to prefer emptiness. Even inside atoms, emptiness rules. This may be one of the most surprising discoveries of modern physics. When people imagine matter, they often picture something solid and continuous. A chair appears solid. A wall appears solid. Your body appears solid. But atoms are mostly empty space. If the nucleus of an atom were expanded to the size of a marble, the surrounding electrons would orbit hundreds of meters away. Almost everything in between would be empty. The solidity you experience comes from electromagnetic forces, not from matter being tightly packed together. In a sense, the emptiness that dominates galaxies also exists within you. The universe repeats this pattern across scales. Atoms are mostly empty. Solar systems are mostly empty. Galaxies are mostly empty. Even clusters of galaxies are mostly empty. Again and again, structure appears as tiny islands surrounded by vast oceans of nothingness. Yet this emptiness is not meaningless. It allows the universe to exist as we know it. If stars were packed closely together, planetary systems might become unstable. Frequent stellar encounters could disrupt the delicate conditions needed for long-term evolution. The great distances provide stability. They create quiet regions where planets can orbit peacefully for billions of years. In a curious way, emptiness makes complexity possible. The silence between stars allows stars to shine. The darkness between galaxies allows galaxies to evolve. The vastness between worlds creates room for stories to unfold. And perhaps that perspective changes how we think about loneliness. When viewed from a human perspective, emptiness can sometimes feel unsettling. But the universe treats emptiness differently. It is not merely absence. It is possibility. It is the canvas upon which everything else is painted. Without vast stretches of darkness, there would be no constellations. Without enormous distances, there would be no galaxies. Without space, there would be no place for light to travel. Even tonight, as you lie beneath the sky, photons from distant stars are crossing unimaginable gulfs of emptiness to reach you. Some began their journeys before recorded history. Others started traveling long before Earth existed. For billions of years, they moved silently through darkness, across regions so empty that human language can barely capture their scale. And eventually, after all that time, a few of those ancient travelers arrived here, into your world, into this moment. The universe may be far emptier than we imagine, but somehow, within all that vast silence, stars still shine, galaxies still turn, planets still orbit, and conscious minds still pause to wonder about the darkness above. Perhaps that is what makes the emptiness beautiful, not because it contains nothing, but because against such overwhelming vastness, the existence of anything at all feels almost miraculous. 10. Some cosmic events last longer than civilizations. The universe often feels dramatic when we think about exploding stars, colliding galaxies, and black holes hidden in the dark. Yet many of the greatest events in cosmic history are not sudden at all. They unfold so slowly that an entire civilization could rise, flourish, disappear, and leave behind only faint traces, while the cosmic process itself barely advances by a noticeable fraction. And perhaps that is one of the strangest truths about reality. Human life feels long from our perspective. A century can contain countless generations of memories, discoveries, and dreams. Entire empires have risen and fallen in less than 1,000 years. Recorded history stretches back only a few thousand years, yet against the backdrop of the cosmos, these spans become almost impossibly brief. There are events happening right now that began millions, billions, or even tens of billions of years ago, and they are still far from finished. As you rest beneath the night sky tonight, some of those immense processes continue silently around you, not rushing, not pausing, simply following the patient rhythm of the universe. One example can be found inside galaxies themselves. Galaxies may appear stable and permanent when viewed through a telescope. Their spiral arms seem frozen in elegant shapes. Their stars appear fixed against the darkness. But galaxies are constantly changing. Stars are being born. Stars are dying. Gas clouds drift. Gravity slowly rearranges entire regions. These transformations occur over timescales so vast that no human observer could ever watch them directly. A spiral galaxy may take hundreds of millions of years to complete a single rotation. Imagine waiting that long to witness one cosmic turn. The entire history of human civilization would pass many thousands of times before the motion became obvious. And yet the galaxy never stops moving. The process continues whether anyone watches or not. Even our own galaxy is part of an event far larger. The Milky Way and the Andromeda Galaxy are slowly approaching one another through space. Their separation is enormous, more than 2 million light-years. Yet gravity is patiently pulling them together. One day they will merge. Not tomorrow, not next year, not even in the lifetime of Earth as we know it. The collision is expected to occur roughly 4 to 5 billion years from now. At first, that number feels almost meaningless. It lies so far beyond ordinary experience that the mind struggles to grasp it. Yet the process has already begun. The galaxies are already falling toward one another. The future merger is not an event waiting to start. It is an event already underway. We simply happen to exist during an extremely early chapter. And the collision itself will not be sudden. Even when the galaxies finally meet, the interaction will unfold over hundreds of millions of years. Stars will rarely collide directly because the spaces between them are so immense. Instead, gravity will slowly reshape both galaxies. Spiral arms will stretch, gas clouds will compress, new generations of stars may ignite. The entire transformation may take longer than many planets remain habitable. The universe often works this way. Its greatest changes are not explosions. They are slow evolutions. Another example lies within stars themselves. When we look at the sun, it seems constant, reliable, unchanging. Day after day, it rises and sets with remarkable consistency. Yet the sun is gradually changing every moment. Deep within its core, hydrogen is continuously being converted into helium. The process has been occurring for approximately 4.5 billion years. It will continue for billions more. From a human perspective, the sun appears eternal. From a cosmic perspective, it is quietly progressing through a long life cycle. The sun is not standing still. It is aging. Every second, every minute, every year. One day it will become brighter, then larger. Eventually it will transform into a red giant. Later it will shed its outer layers and leave behind a dense stellar remnant. But all of this unfolds on timescales so vast that entire species may come and go without noticing any significant change. The story is already being written. We simply occupy one brief page within it. Even black holes participate in processes that dwarf civilizations. Many people imagine black holes as violent cosmic monsters that immediately consume everything nearby. Reality is often much slower. A supermassive black hole at the center of a galaxy can persist for unimaginable lengths of time. It may spend millions of years feeding actively, then millions more in relative quiet. Over cosmic ages, it grows little by little, sometimes by swallowing gas, sometimes by merging with other black holes, sometimes by consuming entire stars that wander too close. These events may seem dramatic, yet from the black hole's perspective, they are merely small moments in an extraordinarily long existence. Some supermassive black holes alive today may continue influencing galaxies long after humanity is forgotten, long after Earth changes, long after the sun itself reaches the end of its life. And perhaps the most astonishing long-term process of all involves the future of the universe itself. The cosmos is expanding. Galaxies are gradually drifting farther apart, not because they are actively flying through space in every case, but because space itself continues to grow. This expansion has been occurring for billions of years, and according to current evidence, it may continue indefinitely. If that happens, distant galaxies will slowly disappear from one another's view, not suddenly, not dramatically, but steadily, patiently. Trillions of years from now, observers living in whatever civilizations might exist would see a much emptier universe than we see tonight. Many galaxies visible today would have faded beyond reach. The grand cosmic web would become increasingly isolated. The universe itself would appear quieter, darker, lonelier. And that transformation is already underway. Right now, at this very moment, the future cosmos is slowly being shaped by processes that began billions of years ago. The remarkable thing is that none of these events require urgency. The universe does not hurry. It does not rush toward conclusions. It works through patience on scales almost impossible for human minds to imagine. And perhaps there is something strangely comforting about that. While our lives are measured in years and decades, the cosmos moves according to rhythms measured in millions and billions of years. The stars do not panic about tomorrow. Galaxies do not fear the future. Black holes do not hurry toward their destinies. Everything unfolds according to the quiet laws that have guided the universe since its earliest moments. As you continue resting tonight, imagine these immense processes still unfolding beyond the darkness above. Galaxies drifting, stars aging, black holes growing, space expanding. Each one part of stories so long that entire civilizations become brief moments within them. And while humanity's chapter may be short compared to the age of the cosmos, we are fortunate enough to exist during a time when we can glimpse these extraordinary stories. We may not live long enough to witness their endings, but we can marvel at the fact that they are happening at all. Right now, tonight, quietly, patiently, across the endless depths of space. 11. The universe is filled with invisible structures. Imagine looking out into the night sky and believing that the universe is mostly made of stars. It feels like a reasonable assumption. After all, stars are what we see. They fill photographs from powerful telescopes. They illuminate galaxies. They create planets. They forge the atoms that eventually become living things. For thousands of years, stars appeared to be the main characters of the cosmic story. But modern astronomy has revealed something far stranger. The shining galaxies scattered across the heavens may be only the visible decoration attached to something much larger and far more mysterious. A hidden framework, an invisible architecture, a cosmic skeleton stretching across billions of light years. A structure so enormous that entire galaxies follow its guidance without ever seeing it. And tonight, as you rest beneath the stars, we are going to drift quietly through one of the most astonishing discoveries in modern science, the realization that the universe is filled with invisible structures, structures that cannot be seen directly, structures that emit no light, structures that may contain far more mass than everything visible combined. And yet, despite remaining hidden, they shape nearly everything we observe. Perhaps the strangest part is that astronomers did not discover these structures by finding them. They discovered them because galaxies refuse to behave the way they should. Sometimes science advances through direct observation. A new planet is seen, a new star is detected, a new galaxy appears in a telescope. But other times, discovery begins with confusion, with something not making sense. In the early 20th century, astronomers started measuring how galaxies move. The expectation seemed simple. If visible matter creates gravity, then the movement of stars should reflect the amount of visible material present. Stars closer to the center of galaxies should move differently than stars farther away. The outer regions should rotate more slowly. Much like planets in our solar system orbit the Sun, Mercury moves faster than Neptune because it is closer to the dominant source of gravity. The same logic seemed likely to apply to galaxies. Yet observations revealed something deeply puzzling. The outer stars were moving far too quickly. Not a little faster, much faster. Fast enough that many galaxies should have flown apart long ago, and yet they remained intact. Something unseen appeared to be providing extra gravity. Something massive, something everywhere, something invisible. At first, many scientists suspected measurement errors. That would have been the simpler explanation. But as observations improved, the mystery only grew stronger. Every new galaxy seemed to tell the same story. Visible matter alone could not explain what was happening. There appeared to be far more mass present than telescopes could detect. It was as though galaxies were embedded inside enormous invisible halos. Halos far larger than the galaxies themselves. Gradually, a new idea emerged. Perhaps most of the universe's matter does not shine. Perhaps most matter neither emits nor reflects light. Perhaps the visible universe is only a small fraction of what truly exists. Today, scientists call this hidden substance dark matter, not because it is dark in color, but because it remains invisible to ordinary light. And if current models are correct, dark matter outweighs ordinary matter by roughly 5 to 1. That means every star, every planet, every moon, every cloud, every ocean, every mountain, every living creature, every human who has ever existed, together represent only a minority of the universe's total matter. The realization is difficult to absorb. Human beings evolved in a world where seeing generally means knowing. We trust our eyes. We trust light. Yet on cosmic scales, light may reveal only a small fraction of reality. Most of the universe could be hidden behind a veil we cannot directly perceive. As researchers began studying dark matter more carefully, an even more remarkable picture emerged. Dark matter does not appear randomly scattered. Instead, it forms enormous structures, gigantic networks stretching across unimaginable distances. To understand this, imagine standing on a mountain at night and looking down at a city. You might see streets illuminated by lights, roads connecting neighborhoods, highways linking distant districts. The pattern reveals an underlying structure. The lights show where the city exists, but they also reveal the framework holding everything together. The universe appears to contain something similar, except on scales so vast that the comparison almost breaks down. Galaxies are not distributed evenly through space. Instead, they gather along immense filaments, long strands containing thousands of galaxies. Those filaments connect to enormous clusters. Clusters connect to superclusters. Between them lie gigantic voids, regions so empty they contain relatively few galaxies at all. When astronomers map these patterns, the result looks surprisingly organic, almost like a web, a network, a cosmic nervous system stretching across the observable universe. This immense arrangement is often called the cosmic web, and according to modern simulations, dark matter forms its invisible scaffolding. Galaxies may simply be the luminous decorations tracing structures that already existed. The idea is breathtaking. Imagine constructing a building. Before walls appear, before windows exist, before lights are installed, a hidden framework must be assembled first. Dark matter may have served a similar role for the universe itself. Long before galaxies fully formed, invisible concentrations of matter were already shaping the landscape. Gravity slowly pulled ordinary gas toward these regions. Hydrogen gathered, stars ignited, galaxies emerged. But the invisible framework came first. In a sense, dark matter may have helped build the stage upon which the visible universe performs. And yet, we still do not know what dark matter actually is. This remains one of the greatest mysteries in science. For decades, researchers have searched for direct evidence. Sensitive detectors have been buried deep underground. Particle accelerators have explored new possibilities. Space missions have searched for clues. But the true nature of dark matter remains elusive. We see its influence, we measure its gravity, we map its effects. Yet the substance itself continues to hide. It is a strange situation. Imagine feeling the wind every day of your life, watching trees bend, watching waves form, watching clouds move, yet never being able to see air directly. Dark matter occupies a similar place in modern cosmology. Its presence seems undeniable. Its identity remains uncertain. And perhaps that uncertainty is part of what makes the mystery so captivating. Because hidden structures are not unusual in nature. Much of reality operates beneath the surface. Roots support forests while remaining underground. Ocean currents shape climates while remaining unseen. Magnetic fields influence matter while remaining invisible. The universe itself may follow the same pattern. Its deepest architecture may be hidden from direct observation. Visible galaxies might simply illuminate a framework that existed long before them, a framework still guiding them today. And as you continue resting quietly beneath the night sky, it is worth reflecting on just how extraordinary that possibility is. The stars above may seem permanent, bright, dominant, important. Yet they could represent only the visible surface of a much larger reality. A reality filled with hidden structures stretching across cosmic distances, invisible bridges connecting galaxies, unseen highways guiding matter, dark frameworks supporting the largest patterns in existence. The universe often appears empty when viewed from Earth, but beneath that appearance lies astonishing complexity. A silent architecture built from forces and matter we are only beginning to understand. And perhaps that is one of the most beautiful lessons astronomy offers. The deeper we look, the more mystery we find. Not because science is failing, but because reality is richer than our first impressions. The stars may be magnificent, yet they are only part of the story. Beyond their light lies an invisible cosmos, a hidden structure still quietly shaping the universe tonight. 12. We are watching the universe remember its past. Every telescope, no matter how powerful, is doing something that seems almost impossible. It is collecting memories. Not human memories, not written records, not stories preserved in books, but memories carried by light itself. Tonight, as you rest beneath the quiet darkness, countless photons are arriving at Earth after journeys so long that they began before mountains rose, before dinosaurs walked, before our planet even existed. Some of those ancient messengers have traveled for billions of years without stopping once. And when they finally reach a telescope, they bring with them tiny pieces of the universe's forgotten past. In a very real sense, astronomy is not simply the study of distant objects. It is the study of memory. The universe is constantly remembering itself, and we are fortunate enough to witness part of that process. The strange thing is that when we look into the night sky, we rarely think of it this way. Stars appear fixed, galaxies appear distant. Everything seems frozen in place. Yet nothing we see is happening right now. Even the light from the moon takes over a second to reach Earth. Sunlight takes about 8 minutes. The nearest star beyond our sun appears as it was more than 4 years ago. The farther we look, the deeper into history we travel. A galaxy 100 million light years away appears as it existed 100 million years ago. A galaxy 1 billion light years away appears 1 billion years younger. Distance and time become the same thing. Every additional mile through space becomes another step backward into cosmic history. And this transforms the entire sky into a vast archive. Imagine standing inside a library so large that every shelf contains a different era of the universe. Nearby stars occupy the most recent shelves. Distant galaxies occupy older ones. Farther still are chapters from a time when galaxies themselves were only beginning to form. The night sky is not a single moment. It is billions of different moments, layered together. Every direction contains a different page from the story of existence, and telescopes allow us to read those pages. This idea becomes even more remarkable when we consider how light actually travels. A photon leaves a distant star, then it crosses unimaginable emptiness. Year after year, century after century, million year after million year. Most photons never arrive anywhere important. Many drift endlessly through darkness. Some are absorbed by dust clouds. Others disappear into black holes. Yet a tiny fraction survive. Those survivors continue their journeys until they finally reach a detector built by an intelligent civilization on a small planet orbiting an ordinary star. The odds seem almost absurd, yet it happens constantly. Right now, ancient photons are arriving on Earth from every direction. Each one carries information. Each one preserves a fragment of history. Each one acts as a messenger from a universe that no longer exists. Because that is the truly fascinating part. The universe we observe is often gone. The galaxies we see today have already changed. Their stars have aged. Their structures have evolved. Some may have merged with neighboring galaxies. Others may have produced entirely new generations of stars. The images we collect are not current photographs. They are preserved memories, snapshots from a reality that has already moved on. In this way, astronomy resembles archaeology. An archaeologist uncovers fossils buried in stone. An astronomer uncovers ancient light buried in time. Both are studying traces left behind by vanished worlds. Both are reconstructing stories from incomplete evidence. Both are trying to understand how the present emerged from the past. The difference is scale. Astronomers perform archaeology across billions of light years. They excavate history using photons instead of shovels. And the deeper they look, the older the discoveries become. Some of the most extraordinary memories ever recovered come from the cosmic microwave background. This faint glow fills the entire universe. It surrounds Earth in every direction. At first glance, it appears uniform, almost featureless. But hidden inside it are tiny variations, tiny temperature differences, tiny patterns, tiny irregularities. These subtle details preserve information from nearly 13.8 billion years ago. They reveal what the universe looked like when it was still young, before galaxies, before planets, before stars, before anything familiar existed. When scientists study this ancient radiation, they are essentially reading one of the oldest surviving records in existence. It is not a record written in words, it is written in light, and it has survived almost the entire age of the cosmos. Few things in nature preserve history so faithfully. Yet even this ancient memory is incomplete. There are chapters we cannot read. There are pages that remain hidden. Before the cosmic microwave background formed, the universe was opaque. Light could not travel freely. Earlier events left fingerprints, but not direct images. Those first moments remain partially concealed behind a curtain of physics. And so the universe continues to keep some of its deepest secrets. This balance between knowledge and mystery is part of what makes cosmology so beautiful. Each answer reveals another question. Each discovery exposes another unknown. Every time we recover a memory from the distant past, we discover evidence of an even older story waiting behind it. The process never truly ends. In fact, the universe itself may eventually erase some of these memories. Expansion continues stretching space. Distant galaxies continue moving farther away. Ancient signals become weaker. Light becomes increasingly redshifted. Over immense spans of time, entire portions of cosmic history may disappear beyond observation. Future astronomers could inherit a much smaller archive than the one available to us today. Some of the evidence we can study right now may not remain accessible forever. This means we are living during a remarkably fortunate era. The universe still remembers enough of its past for us to reconstruct much of its story. The oldest light remains visible. Distant galaxies remain observable. The cosmic record is still open. And that gives our generation a rare opportunity. We are witnesses to the universe remembering itself. Every telescope on Earth contributes to this effort. Every observation adds another piece to the puzzle. Every photon collected becomes another recovered memory. And perhaps there is something deeply comforting about that. The cosmos is unimaginably vast. Its history stretches across billions of years. Civilizations appear and disappear. Stars are born and die. Galaxies collide and transform, yet traces remain. Evidence survives. The story continues to be written across the sky. Tonight, while you rest peacefully beneath the stars, ancient messages are still arriving. Light from forgotten galaxies continues crossing the darkness. Photons that began their journeys before Earth existed are quietly reaching our world. The universe is remembering, and through science, patience, and curiosity, we are learning how to listen. If you're still awake beneath the stars, take a moment to subscribe so you won't miss future cosmic bedtime journeys. For now, allow your thoughts to drift gently through the vast archive of the cosmos. The stars above are not merely lights in the darkness, they are memories. And tonight, those memories continue their silent journey across eternity. 13. There may be places where stars never shine. Far beyond the crowded regions where galaxies gather into immense clusters and cosmic webs, there may exist places so isolated that starlight becomes almost irrelevant. Not because stars never formed there, not because light is forbidden from entering, but because the distances have grown so enormous that the nearest stars may appear as faint, lonely specks scattered across unimaginable darkness. Tonight, as you rest beneath Earth's familiar sky, it is difficult to imagine such places. Wherever we look from our planet, the heavens seem full. Thousands of stars shine overhead. The Milky Way stretches across the darkness like a river of pale light. Even the emptiest patch of sky eventually reveals galaxies when viewed through a powerful telescope. Yet the universe is not equally populated everywhere. Some regions are astonishingly empty, and in the distant future, entire portions of the cosmos may become even more isolated than they are today. To understand why, we must first appreciate just how uneven the universe truly is. Galaxies are not scattered randomly through space. They gather into enormous structures. Clusters contain hundreds or even thousands of galaxies bound together by gravity. These clusters connect through vast filaments of matter that stretch across hundreds of millions of light years. Together they form what astronomers call the cosmic web. On the largest scales, the universe resembles an intricate network of glowing strands. But between those strands lie enormous voids. Regions so empty that they contain far fewer galaxies than average. Some cosmic voids span hundreds of millions of light years. If you lived inside one of these vast regions, the night sky could already look dramatically different from ours. Nearby galaxies would be fewer. Bright clusters would be more distant. The familiar richness of the heavens would slowly fade. And yet even these modern voids may be crowded compared to what the future holds, because the universe is expanding, and that expansion is accelerating. Every year, distant galaxies drift farther apart, not because they are flying through space like spacecraft, but because space itself continues to stretch. The effect is small across local distances. Gravity keeps galaxies within clusters bound together. The Milky Way and the neighboring Andromeda galaxy are actually moving toward one another, but across billions of light years, expansion dominates everything. Galaxies that are not gravitationally connected slowly recede. Over immense periods of time, the distances between them become larger and larger. Eventually, some galaxies move beyond one another's observable horizons entirely. Their light can no longer bridge the expanding gap. Their future signals never arrive. The universe slowly loses contact with parts of itself. Imagine living trillions of years from now. The stars within your local galaxy would still exist. Planets might still orbit them. Civilizations, if any survived, might continue looking toward the sky. But the distant galaxies we see today could be gone. Not destroyed, simply unreachable, invisible. The great cosmic web that modern astronomy studies in such detail would disappear from observation. The universe would appear much smaller than it truly is. An observer living during that distant era might never suspect that billions of galaxies once filled the heavens. Their visible cosmos could consist only of a single island of stars surrounded by overwhelming darkness. In a sense, starlight itself would become rare, not because stars had vanished, but because most of them would lie beyond observational reach. The sky would remember less of its own history. This possibility reveals something remarkable about the age in which we live. Right now, we inhabit a period when the universe is unusually transparent. The evidence of cosmic history remains visible. Ancient galaxies still send their light toward us. The afterglow of the Big Bang still surrounds us. Massive structures remain detectable across enormous distances. We are able to study the cosmos on scales that future observers may never witness. The universe is currently revealing far more of itself than it will someday allow. And yet even today, some places may already experience a kind of cosmic loneliness. Astronomers have discovered dwarf galaxies drifting far from larger systems, small collections of stars isolated in regions with few neighbors. These galaxies still belong to the wider universe, but their surroundings are far quieter than our own. If intelligent beings live there, their view of reality might differ dramatically from ours. Their night skies might contain fewer bright landmarks. Their history of astronomy might unfold differently. The questions they ask about existence could be shaped by a much emptier horizon. Location matters, not just on planets, not just within galaxies, but across the structure of the universe itself. Where you exist determines what evidence reaches you, what light arrives, what history can be observed. Even our understanding of reality depends partly on where we happen to be standing. This idea becomes even more fascinating when we consider the largest cosmic voids. Some of these regions are so enormous that a traveler crossing them would encounter very little. No great clusters, no brilliant concentrations of galaxies, only occasional isolated systems separated by immense stretches of emptiness. The journey would not feel like crossing a city, or even crossing a continent. It would feel like drifting across an ocean larger than imagination itself. And yet these voids are not mistakes. They are natural products of cosmic evolution. Gravity pulls matter into dense regions. As matter gathers into filaments and clusters, other regions become increasingly empty. The universe develops contrast. Structure grows in some places while emptiness deepens in others. Over billions of years, this process creates a cosmos where both abundance and isolation coexist. Light and darkness, crowding and loneliness, presence and absence. The universe contains all of them simultaneously. What is perhaps most surprising is that even extreme emptiness is not truly empty. Quantum fields still exist. Dark matter still passes through. Radiation still drifts between galaxies. Space itself remains active. Even the quietest regions participate in the larger cosmic story. The darkness is not nothingness. It is simply a different form of existence. A place where events unfold more slowly, where distances dominate experience, where silence becomes the defining feature of reality. And perhaps that silence carries its own kind of beauty, because emptiness allows scale to reveal itself. When surrounded by countless stars, it is easy to focus on individual objects. But when the sky grows sparse, the vastness becomes impossible to ignore. The darkness itself becomes part of the experience, a reminder that the universe is not merely a collection of shining things. It is also the immense space between them, the great stage upon which every galaxy, every star, and every planet exists. As you continue resting tonight, imagine those distant regions, places where starlight may someday become little more than a faint memory, places where darkness stretches for unimaginable distances, places where the universe appears quieter than anywhere we have ever known. And yet, even there, the same laws of nature continue their patient work. Gravity still shapes matter. Time still flows forward. Space still expands. The cosmos remains alive, even in its loneliest corners, even in its deepest darkness, even where the stars themselves seem almost absent. 14. The universe began in near-perfect simplicity. If we could somehow travel backward through time, farther than the birth of Earth, farther than the formation of the sun, farther even than the first stars, we would arrive at a universe almost unrecognizable compared to the one we know today. No galaxies, no planets, no oceans, no mountains, no living creatures gazing upward and wondering how everything began. In fact, there would be almost nothing to distinguish one region from another. The universe would appear astonishingly simple, and perhaps that is one of the greatest surprises in all of cosmology. The breathtaking complexity surrounding us today may have emerged from a cosmos that was once remarkably uniform, a place where the ingredients of existence existed in their simplest possible form. Tonight, as you rest quietly beneath the stars, imagine peeling away the layers of cosmic history, removing galaxies, removing stars, removing planets, removing every structure that gravity has spent billions of years constructing. As we travel backward through time, the universe gradually loses complexity. Galaxies disappear first, then stars vanish. Then even atoms themselves begin to break apart. Eventually, we reach an era when the entire observable universe resembles an almost featureless sea of energy and particles. And yet, hidden within that simplicity were the seeds of everything that would come later. The story begins with one of the most extraordinary observations ever made. When astronomers examined the oldest light in the universe, the faint glow known as the cosmic microwave background, they discover something remarkable. The young universe was astonishingly smooth. Not perfectly smooth, but incredibly close. Temperature differences across enormous distances amount to only tiny fractions of a degree. The early cosmos appears almost uniform in every direction. This is surprising because the modern universe is anything but uniform. Today we see enormous structures everywhere. Galaxies cluster together. Stars gather into spiral arms. Planets orbit stars. Life evolves on at least one small world. Complexity seems woven into every corner of existence. Yet all of that emerged from a beginning that appears extraordinarily simple. This raises a profound question. How does complexity emerge from simplicity? How does a nearly uniform universe transform itself into a cosmos filled with countless forms, structures, and possibilities? The answer begins with tiny imperfections. The early universe was not perfectly smooth. Tiny fluctuations existed, small differences in density, small variations in temperature, microscopic irregularities. At first, these differences were almost unimaginably small, yet gravity possesses extraordinary patience. Over millions and billions of years, those tiny variations grew. Regions containing slightly more matter attracted additional matter. Denser regions became denser still. Gradually, structure emerged. The process resembles something surprisingly familiar. Imagine a calm lake. Its surface appears smooth. Then, a tiny ripple forms. The ripple spreads, interacts with other ripples, produces larger patterns. Eventually, complexity emerges from what initially seemed simple. The universe followed a similar path. Small irregularities became galaxies. Galaxies became stars. Stars forged heavy elements. Heavy elements formed planets. Planets created environments where chemistry could become increasingly complex. Complexity built upon complexity, layer after layer, generation after generation, across cosmic time. And yet every stage depended upon those tiny initial differences present from the beginning. Without them, the universe might look dramatically different today. Perhaps there would be no galaxies, no stars, no planets, no life. A perfectly smooth universe might have remained largely featureless forever. In a strange sense, existence may owe its richness to tiny imperfections. The cosmos became interesting because it was not completely uniform. This idea carries a certain beauty. Many of us grow up believing perfection is desirable. Yet nature often creates its greatest wonders through imperfections. Snowflakes form intricate patterns because of small variations. Coastlines become beautiful because they are irregular. Clouds take fascinating shapes because they are unstable. The universe itself may have become capable of producing life because it was never perfectly smooth. Tiny asymmetries allowed everything else to follow. The deeper scientists investigate this story, the more remarkable it becomes. Modern physics suggests that some of those early fluctuations may have originated from quantum events, tiny uncertainties existing at microscopic scales, fluctuations so small they seem insignificant. Yet during an early period known as cosmic inflation, space itself may have expanded enormously. Those microscopic fluctuations became stretched across vast distances. What began smaller than an atom eventually became large enough to influence entire galaxies. This connection between the very small and the very large remains one of the most astonishing ideas in science. The largest structures in existence may trace their origins to tiny quantum fluctuations from the earliest moments of time. The cosmic web. Galaxy clusters, superclusters, perhaps even the Milky Way itself, all may represent the amplified echoes of unimaginably small beginnings. The universe appears to possess an extraordinary ability to create complexity from simplicity, and nowhere is that more evident than in the story of chemistry. The early cosmos contained mostly hydrogen and helium, simple elements, simple atoms. For millions of years, little else existed. The heavier elements necessary for rocky planets and living organisms had not yet formed. Carbon did not exist in significant amounts, neither did oxygen, nor iron, nor calcium, nor silicon. The ingredients required for oceans, mountains, and biology simply were not present. They had to be created. Stars became the great cosmic factories responsible for that transformation. Deep inside stellar cores, nuclear fusion forged new elements. When massive stars died, they scattered those elements across space. Future generations of stars inherited increasingly complex materials. Planets formed, chemistry expanded, possibilities multiplied. What began as a universe dominated by simplicity gradually became capable of extraordinary diversity. Every tree, every ocean, every animal, every human thought, every work of art, every dream, every question ever asked, ultimately emerged from particles that once existed in a much simpler state. The transformation is difficult to fully appreciate. Complexity did not arrive suddenly. It accumulated, patiently, over billions of years, each generation building upon what came before, each layer creating opportunities for the next. In some ways, the universe resembles a long story that continually adds new chapters. The opening pages were simple, almost minimalist. Only later did the narrative become increasingly rich. And perhaps the most extraordinary chapter of all involves consciousness itself. Because eventually, after billions of years of cosmic evolution, the universe produced beings capable of reflecting upon its own history. Atoms organized themselves into living systems. Living systems developed awareness. Awareness developed curiosity. And curiosity led to science. Now the universe studies itself through minds that emerged from its own processes. The simplicity of the beginning eventually gave rise to creatures capable of asking how everything began. That realization remains one of the most beautiful consequences of cosmic evolution. The early universe did not contain observers. It did not contain astronomers. It did not contain questions. Yet hidden within its simple beginnings existed the potential for all of those things, including you. As you lie quietly beneath the night sky tonight, It is worth remembering that every complex thing around you traces its origins to a cosmos that was once astonishingly simple. The stars overhead, the earth beneath you, the air you breathe, the thoughts moving through your mind, all emerge from a universe that began with far less structure than we see today. The journey from simplicity to complexity remains one of the greatest stories science has ever uncovered. And perhaps it offers a comforting perspective as well, because even the most extraordinary realities can emerge from humble beginnings. The vast richness of the modern cosmos was not present from the start. It grew, slowly, patiently, over unimaginable spans of time. And even now, that process continues. The universe is still evolving, still creating, still transforming, still turning simplicity into wonder. 15. Future civilizations may know less about the universe than we do. Imagine a civilization living trillions of years in the future. Its scientists are intelligent. Its technology is advanced beyond anything humanity can currently imagine. Its observatories are vast. Its understanding of mathematics is profound. And yet, despite all of that knowledge, those future astronomers may know less about the universe than we do today. Not because they are less capable, not because they failed to ask the right questions, but because the evidence itself may have vanished. The universe could gradually hide its own history, and future civilizations may inherit a sky that reveals far less than the one above us tonight. At first, this idea sounds backward. We usually assume knowledge increases with time. Later generations benefit from earlier discoveries. Technology improves, measurements become more precise, understanding grows. In most areas of science, this pattern holds true, yet cosmology may be different, because astronomy depends on something precious, evidence, and evidence can disappear. As you rest beneath the stars tonight, countless galaxies remain visible beyond the Milky Way. Powerful telescopes can detect billions of them. Astronomers can measure their distances, study their motions, observe their evolution, and most importantly, use them to understand how the universe itself behaves. The expansion of space, the existence of dark energy, the large-scale structure of the cosmos. All of these discoveries depend upon observing distant galaxies. But those galaxies will not remain visible forever. The universe is expanding, and that expansion is accelerating. Every year, distant galaxies drift farther away. The light they emit becomes increasingly stretched, increasingly redshifted, increasingly faint. Over immense spans of time, many of those galaxies will disappear beyond observational reach. Future observers may never see them at all. To understand why this matters, imagine trying to reconstruct human history after every book had been destroyed. No documents, no photographs, no monuments, no records. The events still happened, but the evidence is gone. The challenge facing future cosmologists may be surprisingly similar. The universe's history will remain real, yet much of the evidence revealing that history may gradually fade from view. One of the most important discoveries in modern astronomy came from observing distant galaxies moving away from us. The farther a galaxy lies, the faster it appears to recede. This pattern revealed that space itself is expanding. Later observations showed that expansion is accelerating. That discovery transformed our understanding of the cosmos. It revealed the influence of dark energy. It changed predictions about the future. It reshaped cosmology itself. But imagine a future civilization existing long after most external galaxies have vanished beyond the cosmic horizon. Such observers might look outward and see only their local galactic system. Without distant galaxies to compare against, how would they discover expansion? How would they detect dark energy? The crucial evidence could simply be absent. The universe would provide fewer clues. And fewer clues often mean fewer conclusions. The situation becomes even stranger when we consider the cosmic microwave background. Today, this ancient radiation fills the sky. It serves as one of the strongest pieces of evidence supporting the Big Bang. Astronomers study it constantly. It reveals conditions from nearly 13.8 billion years ago. It preserves information from the young universe. It acts as a fossil made of light. Yet the cosmic microwave background is also changing. Expansion continually stretches its wavelengths. Over unimaginable periods of time, the radiation becomes weaker and harder to detect. Eventually, it may be stretched so dramatically that future observers struggle to observe it at all. The sky would lose one of its oldest surviving memories. An entire chapter of cosmic history could effectively disappear. Future astronomers might never know it existed. And if both distant galaxies and the cosmic microwave background become inaccessible, the consequences are remarkable. Future civilizations could look outward and see a universe that appears static, small, isolated, perhaps eternal. The evidence suggesting a hot, expanding origin might be hidden completely. They could develop cosmological theories very different from our own, not because they are wrong, but because they would be working with different evidence. This idea teaches something profound about science. Scientific understanding depends not only on intelligence, but also on observation. Even the greatest minds cannot study evidence that no longer exists. Knowledge requires access. The universe determines what information remains available, and availability changes with time. In that sense, cosmology is partly a historical science. We live during a particular era, a particular window, a particular moment when certain observations remain possible. Future observers may inherit a different universe. Not physically different, but observationally different. And that distinction matters enormously. The thought becomes even more fascinating when we realize how fortunate our era may be. Humanity emerged during a period when the universe remains rich with accessible information. The cosmic microwave background is still observable. Distant galaxies still fill the sky. Large-scale structures remain visible. Ancient light continues arriving. The evidence required to reconstruct cosmic history remains available. We are living during a time when the universe still tells much of its story. Not all of it, but enough. Enough to uncover expansion, enough to discover dark matter, enough to detect dark energy, enough to estimate cosmic age, enough to trace our origins back billions of years. That opportunity may not last forever. Some scientists have described this as a kind of cosmological coincidence. Not necessarily a coincidence in the supernatural sense, but a fortunate circumstance, a moment when observers happen to exist while crucial evidence remains accessible. We often think of ourselves as arriving late in cosmic history, after countless stars have already lived and died, after galaxies have evolved for billions of years, after much of the universe's story has already unfolded. Yet, in another sense, we may have arrived surprisingly early enough to witness evidence that future civilizations could lose forever. The universe is constantly changing, not only physically, but observationally. The available clues evolve. The visible record evolves. The cosmic archive evolves. Some pages remain open, others gradually fade. Perhaps this realization adds a new layer of meaning to astronomy. Every observation becomes slightly more precious. Every photon collected from a distant galaxy becomes part of a record that may someday be impossible to obtain. Every map of the cosmic microwave background becomes a preserved memory. Every survey of the large-scale universe becomes a snapshot of evidence that future generations may never directly witness. We are not merely studying the cosmos. In some sense, we are documenting a fleeting stage of cosmic visibility, preserving information while it remains accessible, recording a universe that future observers may struggle to reconstruct. And perhaps there is something deeply humbling about that. Humanity often appears small compared to the scale of the cosmos, a brief species on a small planet orbiting an ordinary star. Yet we exist during a remarkable moment, a moment when the universe still reveals much of its past, a moment when ancient light continues arriving, a moment when the great cosmic story remains readable. As you rest beneath the night sky tonight, imagine those distant future astronomers, looking upward from a far older universe, searching for answers, wondering where everything came from, trying to reconstruct a history that has become increasingly hidden. They may possess technologies beyond our dreams, yet some of the evidence available to us tonight could already be gone. And so, in a curious twist of cosmic fate, our era may be one of the best times that will ever exist for understanding the universe itself. The cosmos is still speaking. Its ancient messages are still arriving. Its history remains visible. And for now, at least, we are here to listen. 16. Reality may be stranger than any theory we have today. For thousands of years, humanity has pushed against the boundaries of the unknown. We have mapped continents, measured the motions of planets, discovered galaxies beyond the Milky Way, decoded the age of stars, learned that the universe is expanding, detected black holes, observed the afterglow of the Big Bang. And yet, despite all of these achievements, a remarkable possibility remains. The deepest truths about reality may still be hidden beyond the limits of our current understanding. Not because we lack intelligence, not because science has failed, but because existence itself may be far stranger than anything we have imagined so far. Tonight, as our journey through the cosmos slowly approaches its end, we arrive at perhaps the most profound mystery of all. The possibility that reality is not only unknown, but unknowably deeper than we currently realize. History offers a powerful lesson. Again and again, humanity has believed it understood the universe, and again, reality revealed something unexpected. Ancient civilizations believed Earth stood at the center of creation. The stars appeared fixed, the heavens seemed permanent. The cosmos looked simple. Then new observations arrived. Earth became one planet among many. The sun became one star among billions. The Milky Way became one galaxy among trillions. Every time we expanded our understanding, reality turned out to be larger than expected, more complex, more surprising, more beautiful. And there is little reason to think that process has ended. Consider dark matter. Today, astronomers can measure its gravitational influence throughout the universe. Galaxies rotate too quickly without it. Clusters contain more mass than visible matter can explain. The cosmic web itself appears shaped by its presence. Yet, despite decades of study, we still do not know what dark matter actually is. We can observe its effects, but its true nature remains hidden. It accounts for most of the matter in the universe, and yet we do not fully understand it. Then there is dark energy, perhaps even more mysterious. Dark energy appears responsible for the accelerated expansion of the universe. It shapes cosmic destiny. It determines the future evolution of space itself. And yet its origin remains one of the greatest unsolved problems in physics. The majority of the cosmos appears governed by ingredients we cannot directly explain. This alone should inspire humility. Much of reality remains concealed behind a veil of uncertainty, and these mysteries exist within a universe we can already observe. Beyond that lies an even larger frontier, the unknown beyond observation itself. There are regions of the universe whose light may never reach us, entire cosmic histories unfolding forever beyond our horizon. Perhaps they are similar to our own region. Perhaps they are different in ways we cannot imagine. Science can construct possibilities, but evidence becomes increasingly difficult to obtain. The observable universe may be only a tiny portion of a much larger reality. If so, our current understanding resembles a map drawn from a single island, while an entire ocean remains unexplored. This does not diminish what we know. Rather, it reveals how much remains to be discovered. Even the nature of time continues to challenge us. In everyday life, time feels obvious. Moments pass. Causes create effects. The future becomes the present becomes the past. Yet modern physics paints a more complicated picture. Relativity shows that time can stretch and slow. Different observers experience different durations. Gravity influences the flow of time itself. At quantum scales, additional mysteries emerge. Some theories suggest that time may not be fundamental at all. Perhaps it emerges from deeper structures we do not yet understand. If that is true, one of the most familiar aspects of existence may be far stranger than it appears. Space itself may hold similar surprises. We often imagine space as an empty stage upon which events unfold, but modern physics suggests otherwise. Space bends, expands, carries energy, interacts with matter. Some theories even propose that space may emerge from more fundamental relationships hidden beneath reality. The empty vacuum may not be truly empty. The fabric of existence may possess layers we have only begun to explore. And then there is perhaps the deepest mystery of all. Why does anything exist? After centuries of scientific discovery, this question remains remarkably difficult. Physics can describe how the universe evolves, how stars form, how galaxies grow, how particles interact. But the question of why existence itself exists remains open. Why are there laws of nature at all? Why is there something rather than nothing? Why does reality possess the particular structure we observe? These questions sit at the edge of science, philosophy, and human imagination. No complete answer currently exists. Perhaps future generations will discover one. Perhaps the question itself reaches beyond what any civilization can fully understand. And that possibility is worth considering, because reality may not be obligated to fit comfortably inside the human mind. The universe evolved long before human beings appeared. Its deepest structures were not designed for our intuition. Our brains evolved to navigate landscapes, recognize faces, and survive on a small planet. They did not evolve to comprehend quantum mechanics, curved space-time, or the birth of galaxies. The fact that we understand as much as we do is already extraordinary. Yet there may be truths so vast, so abstract, or so unfamiliar that they challenge the limits of cognition itself. Future discoveries may appear as strange to us as modern cosmology would appear to someone living thousands of years ago. Concepts we cannot currently imagine may someday become fundamental. New layers of reality may await beyond every horizon of knowledge. That possibility is not discouraging. It is beautiful. Because mystery is not a failure of understanding. Mystery is what drives discovery. Every unanswered question creates space for wonder. Every unknown invites exploration. Every hidden truth reminds us that the universe remains alive with possibility. And perhaps that is one of the most comforting ideas of all. No matter how much we learn, reality continues to exceed our expectations. The cosmos remains larger than our theories, deeper than our models, more surprising than our predictions. The story is not finished. It may never be finished. There will always be another question, another mystery, another horizon, another reason to look upward. As our journey through these cosmic mysteries comes to a gentle close, it is worth remembering how remarkable this situation truly is. The universe has spent nearly 14 billion years evolving. Stars have lived and died. Galaxies have merged. Planets have formed. Life has emerged. And somewhere within that vast history, the cosmos produced beings capable of wondering about its nature, capable of asking questions, capable of seeking answers, capable of imagining realities beyond their current understanding. That alone is extraordinary. And so tonight, as the stars drift silently overhead and the universe continues its quiet work beyond the darkness, allow yourself to rest in that sense of wonder. Not every mystery needs to be solved immediately. Not every question requires an answer tonight. Some mysteries are valuable simply because they remind us how vast reality truly is. Thank you for joining this peaceful voyage through some of the deepest mysteries of existence. As the universe continues expanding beyond the stars, allow your thoughts to grow lighter, your breathing slower, and your mind calmer. Sleep peacefully tonight, knowing that whatever the ultimate truth may be, countless wonders are still waiting beyond the horizons of human understanding.